Implicit differentiation is what we want to look at. And if we are given an equation of this form, then we are told to find dy dx. Because we have a combination of both x and y into the equation, then we're going to apply the knowledge of the implicit differentiation. So I'm going to differentiate everything with respect to x. Everything will be differentiated with respect to x. And definitely if I differentiate to 0, it remains 0. We already know that this will be 0 because this is a constant. So at least that is sorted out. Now let's look at the others. Now if I differentiate x with if I find d dx of y, it will give me 0. So what I'm going to do is I'll apply a little trick with some knowledge of the chain law. So what you can look at it from a very simple form is this dy and this dy would cancel out. But you have introduced a dy so that dy can be able to differentiate y comfortably. Now when I come here to the second one, d dx of x squared, I know that one will give me a 2x. Now when I come to d dx of xy, it will be an equation of this form, because there I'll apply the knowledge of product rule. So I keep x aside, I differentiate y, and then the second time I keep y aside, I differentiate x, and then that will be 0, and then that will be equals to 0. So I still have to apply the principle of implicit form there. Not explicitly, but implicitly, because of the virtue that it is a y. So if I look at this equation, what does it tell me? D dy of y is 1. So I'll be left dy dx, because I'll be left with 1, plus 2x plus x d dy of y. Then I have dy dx to take care of this part in yellow there. And then plus y times 1 is equals to 0, because d dx of x is not 0. So that's how I'll end up with that part. Now, once that is done, I know what I'll get here. Definitely this will be 1 without writing so many terms. So I'll have dy over dx plus 2x plus x dy over dx plus y is equals to 0. So that's the equation that I'll be left with. So I want to put the dy dx together, and therefore dy over dx 1 plus x is equals to minus y minus 2x. So I'll take x, 2x, and y on the other side of the equation. And that's what I would be left with. So the equation slightly changes from the terms that I have. And that's what I'll end up with. Therefore, my dy over dx will be equals to minus y minus 2x all over 1 plus x. And that will be the final solution to that equation, that y squared plus 2x plus 3xy is equals to naught, or to 0. So I want to differentiate everything through with respect to x, because I want to find dy all over dx. So I'm going to look for the d dx of y squared plus 2 d over dx of x plus 3 d over dx of xy, and that will add up to, everything should be equals to 0. Yes, I factored out the constant because I don't need it. So I'll move a little bit faster if you allow me. D dy of y squared dy over dx plus 2 times 1 plus 3x d over dy over dx. Now remember, this part we are going to use the product rule because there is x and y. So now I've worked with y. Now I want to work with x, and that gives me 0. So what does that mean? So it is 2y dy over dx plus 2 plus 3x dy over dx plus 3y is equals to 0. So that's what we get from that. When I put like terms together, dy dx, dy over dx, that's dy over dx, 2y plus 3x. Then I take everything else to the other side, which is minus 2 minus 3y. So then my equation simplifies, and I'm able to get my dy over dx, which is equals to minus 2 minus 3y all over 2y plus 3x. X squared plus y squared is equals to 1. So d dx of x squared, d dx of y squared is equals to d dx of 1. It's slightly simple because this is 2x. Then here it will be d over dy of y squared times dy over dx is equals to 0. When you differentiate 1 with respect to x is 0. So it is 2x plus 2y dy dx is equals to 0 over dx is equals to minus 2x all over 2y, which is minus x over y. Find d squared y over dx squared. Remember, d squared y over dx squared will be the d over dx of dy over dx. So we'll be getting d over dx of minus x over y, dx of negative x raised to power negative 1. D squared y over dx squared is equals to d over d is equals to negative x d over dx of y negative 1 minus y to power minus 1 d over dx of x. This one we know. This one will automatically give us 1. This one will give us d over dy of y to power minus 1 dy all over dx. And since we have that knowledge, then this will give us negative x. If you differentiate this, you take the negative down there, and then you reduce the power by 1. So this gives me negative 1 y raised to minus 2 dy dx minus 1 over y. And that is the square. I know it's looking a little bit clumsy, but you'll be fine. So this becomes positive. But remember, we are we are familiar with the solution for this part component here, and that component from our previous computations gave us negative x over y. Therefore, we can comfortably say the solution is negative x squared over y cubed minus 1 over y. Or if you wish, you could say it is y cubed negative x squared minus y squared. And that gives us the solution to that. That is plus, and that gives us the solution to that equation. If you want to go back and make it slightly better, you could have written it this way. Why are we writing it this way? Our original equation that we gave, we had said that x squared plus y squared is equals to 1. So all these are possible solutions to that implicit differentiation.